This place is fascinating.
Yeah.
I mean, look at how bright and large and just built out this place is. So our first field trip to cover a physical data center couldn't be a better one. I mean, as you're looking around, this is Cisco's first from the ground up data center. Out of 50 some odd data centers they've got, 13 of which are in production. This is going to become one of the ones redundant in an active-active configuration with the Richardson data center, DC1 to DC2.
Yeah.
But as you're walking around here, what's jumping out at you? What kind of stuff you think is valuable? Because we don't get to cover this kind of stuff normally.
I love that this place is really close to some good restaurants. I think that's a big piece here too.
All right.
But besides that, I think the thing that really sticks out to me is how warm it is in here. You know, I mean, this
I thought it was me. I thought it was hot flashing.
I mean,
this is warmer, isn't it?
This is an effect of the new ASHRAE standards that say that we can go from 65 to 78 degrees, which is quite
Huge
a jump. Yeah, absolutely. So, you know, the ability to make that kind of jump really saves us a lot of cash, but it allows us to really plan data centers out a lot differently. So, I mean, if we could start kind of at the ground floor, you'll notice that, you know, we're solid floors here. There's no raised floor. And the advantage that gives us is number one, we don't have to immediately plan for what our end game is, what our data center, what's our final capacity going to be. We can say these are solid floors, and then we just kind of grow as we need to.
Well, let's talk about the additional reasons why they would do that, because the ASHRAE standards actually give us a wider range to play in.
Yeah.
In this building, which we'll talk about further with airside economizers and different things that they do from a green, they're pursuing a full gold LEEDs certification, which is no small matter when it comes to...
there's no marketing fluff to that. Gold LEEDs, that's pretty hardcore stuff, man. You really...
So I don't think they've even got it, so you can't even claim that yet, because there's really everything from construction and design all the way through actual production, and so we'll see examples of that throughout. But talk about airflow, because you mentioned the hard floors. Notice there's no ceiling as we look up here as well.
Yeah.
What is it that we're seeing from a design perspective that was, is it because ceilings are expensive, or there's probably an airflow consideration for this, right?
Well, what we did is that we worked with, now see, you're saying green. I'm not a big fan of green. You know, I think that green is kind of, I think it's a very overused
But the principle we're talking about is the same. Don't beat me up on the
word. But the principle of living in harmony with the natural order of things works really well here. So if you look up in the ceiling here, is that yeah, there's no hard ceiling, you know, per se, no tiles or anything like that, but we're using the ceiling as a plenum.
Yeah.
You know, so then if you switch over here to the server racks, then what you see is we got chimneys on every single one of these racks. That what it's doing is it's really allowing that hot air, that, you know, that 120-degree air to rise naturally, go up into the ceiling acts as a plenum, and it funnels it off. And then we're using fresh air. As you can see, the white ducts here next to the LED lights.
Right.
The fresh air is kind of swooping down, and it's being sucked into the
because it's going to fall naturally in that cold aisle.
Absolutely.
The equipment fans are going to suck it through.
The
chimney raises it, and it's purposely. It looks like the chimneys end purposely from a stratification perspective above where that cold air layer is, right?
Absolutely.
So
the
two
you don't
aren't
have
fighting.
rain. Yeah, you don't have rain in your data center.
Literally, people have rain. That seems like that would be a bad thing.
Yeah, you definitely don't want that.
Okay.
That's a big problem, especially some of the older DCs. Is you have that mix and you have rain kind of come in there. So this actually kind of prevents, and you got this nice cyclic action of that hot air and cold air.
So while we're still talking about water in this ceiling for a moment, I also noticed what appears to be extremely standard fire suppression. I mean, seeing, to me, this would make me very nervous because you're seeing regular sprinkler heads. What's the story with that?
So that's something that really caught me too when I was in here, is that when I walked into this data center, first thing I started looking for was the respirators. Because we're using like FM200 or
I thought your heart was giving you trouble, no? Oh, okay.
Well, that's something different. But you know, for emergency escape, if we need those. Now, what they decided to use was to use natural water. These are dry pipes filled with nitrogen, and so that if they have an alarm tripped, what they'll do is they'll flood this place out with water. Now, a couple things here. That sounds pretty darn scary, but this is a two-way confirmation system.
Oh.
When you pull the alarm, that is stage one, but just like launching a missile, right? You need two keys. We also have detectors that have to sense that there's smoke.
Oh, the VESA detector that's on the wall. Okay.
Absolutely. So you got to sense smoke, you got to sense heat rise, and then that's going to activate the system. So just one key is not going to launch the system, if you will.
Very good.
That's a really nice way to do this. Number two, water doesn't affect data. Yes, it shorts out electronics. Yes, it shuts it down. But Halon, FM2, that damages electronics too.
Which puts people in danger, raises your cost of all the emergency things you have to have. Because it's a large place to have all those respirators sitting around, right?
Absolutely.
And
you
the training involved.
got to maintenance that, you got to train them, you got to keep them up. Realistically, it's cheaper and more efficient to just use water.
So final point in here real quick, looking at the ceiling again, I noticed not only have they cabled, it looks like things that aren't even, they've terminated all the way down, even if there's not equipment in the racks yet, so they're ready for growth here. But the electrical cabling looks like the busway systems, they're dropping in a higher voltage here as well, correct?
Well, so that's the European voltage standard, that's the 480 that we're dropping in here. And, you know, we could literally do a whole show on this and why that's a real advantage. The big piece is that it does two really important things for any type of data center administrator. It allows us to get rid of a stage 1 step-down transformer. That's why in here...
Which you almost have on a per rack basis, right?
Absolutely, yeah, you don't hear any whine. Typically, you hear those data centers whining, right? You don't hear that in this data center because we're using 480. 480 is being dropped off on each one of these bus bars, and we're dropping down to 30 amps because we're not using 208. We don't have to use 60 amp supply gear. You know, you actually cut your amperage in half, which means you also can decrease your cable size. Cutting your cable size by half, what it really means is you cut your cable cost by half.
Yeah.
You cut your cable weight by half, and copper weighs a lot. So it's a really nice advantage actually going to that.
And the conversion
standard.
process generates heat, you waste, you don't get as much out as you did at the beginning of the process.
Yeah.
So a lot of nice things from a green perspective as well there, right?
Living in harmony, man, living in harmony.
Can we take a look at the rack and kind of talk more specifically about how
I really want to show you some of the labeling stuff they did. That's pretty darn cool.
All right.
So let me show you, I think one of the most impressive things to me. Now this is the business end of the UCS cluster.
Right.
And I think that what I like the best is really the forethought that went into this, is that every single thing, every port that could be labeled or could be plugged in here is actually plugged in. That gives us the ability to really just wire this one time, and then we can control and modulate our bandwidth, our applications, whatever, remotely. We'll have to send somebody out to run another cable or anything like that. We actually have the ability to really control this remotely and truly have a real lights-off data center if everything is cabled up. Now, another big piece, and the thing I like about this entire complex, my thing I'm the most impressed about, is how unbelievably anal retentive they were about labeling everything. I mean, look at this one rack. Out of the hundreds of racks in here, this is replicated all these times, is that everything in here is labeled, and they're labeled with the correct wiring labels as well. This conforms to the TIA standard. They're zip tied on both ends. They're very durable, so that every little piece in here, every power cord, even the fiber optics is labeled in here, which is pretty darn impressive. Now, I'll tell you something else that really gets me in here, is that not only are they labeled, everything is actually even RFID tagged as well, so that now we can actually track your access points all over this place, and we can track this stuff with RFID tags as well.
Well, one of the key principles that was amazing to me is the fact that you RFID tag down to the blade level. So at any given moment, they know not only where everything is physically located, but they're measuring things down to the kilowatt load. So they know through these intelligent power strips, smart strips, you know, that exactly what are we pulling, what are we capable of pulling, so that you can really maximize utilization from end to end on the data center. And you know, are we balancing that magic act of when everything is full and fully utilized, did we use up all of our available power? Can we fail over exactly what we want to fail over? And things of that nature. So the RFID tracking in there as well. I feel the heat coming off of here, so just not to beat this point up too much, but we talked about the solid floors. We're pulling from the cold aisle on the other side. We've got these solid doors here. Normally then this is going to flow up that chimney right there and just naturally go back into that system for recooling the air back into the cold aisle, right?
Yeah, and you mentioned the other side. Let's walk around there and take a look at the more colorful end, and let me show you that side.
All right.
Obviously from the front of the cabinet you can see that we've got a well-vented front door, so we can bring in that cool air. You can actually feel the equipment sucking that air in right now. We go ahead and pop this open. You can actually see how we've carried this RFID asset tag tracking.
Easy for you to say.
Exactly. Down to each individual blade and chassis in here. So this is done as a forethought and not an afterthought. They're plugged in. We can track them right from the start. Very, very cool.
Well, so it's all about utilization, right? So these guys can track it down to see how much we're using at any given moment for the really tying in the virtual and the physical, which becomes necessary to prevent some of that VM sprawl that we see a lot of. And then they've got a very flat network here as we go in. Of course, we got out-of-band management, but then we've got unified fabric all the way back.
Fabric extenders going back to the 7Ks, blanking panels, of course, you know, good data center design, you know, that kind of stuff.
So a lot of stuff to look at. Let's close that sucker up because we have got a full agenda. So on to the rest of the data center, I think. Makes sense, yeah?